Hello, dear friends. This is Dr. Pramod P. Today we will discuss a very interesting topic, and that is synchronous counter design using structural modeling. That is, in Verilog we can have a different modeling styles, and in that we will be using structural modeling for designing a 3-bit synchronous up counter. Before directly discussing the Verilog code, let's have some preamble for this circuit. This is a 3-bit synchronous counter, up counter it is. That is, it starts its counting sequence from 000 to 111. So we will be having with 3 bits, we will be having 2 raised to 3 equal to 8 states in the sequence. As far as deriving the expression of D0, D1 and D2 are concerned, that is D inputs of the 3 flip-flops are concerned, we should either go for K-map or Boolean algebra reduction techniques. Anyway, we may get the expressions as D0 equal to Qn naught, D1 equal to Q1 XOR Q naught, and finally D2 equal to Q2 XOR with Q1 and Q0. Now let's see how to develop Verilog code for this. At first we need to see all the interconnections and all the instances, maybe for flip-flops or for the gates. So here, as per the diagram, I have identified 7 wires or interconnections. They are respectively SD0, SD1, SD2, SQ2, SA10, SQ0 and SQ1. As we know, after that we need to assign Q0, Q1, Q2 are respectively assigned the wire values SQ0, SQ1 and SQ2, and now we should have the instantiation of different D flip-flops over here. They are repeated. So DFF1 is the flip-flop code that I have written. The module is DFF1. So I am taking the instances of it, 3 instances. The first one is DFF10, and for that you will be able to find the input. Yeah, it is indicated as dot D. Within bracket its value will be that of the wire SD0, and for clock the value will be clock itself. Then for Q it will be SQ0, and for Qn it is SD0, and we can have 2 more instances, and they are DFF11 and DFF12. Now the entire program is written over here. The module name is Sync DFF3. The idea over here is any name you can give. The idea over here is synchronous counter. It uses D flip flop, and it's a 3-bit counter, and the inputs are clock and outputs are Q0, Q1 and Q2, where Q2 is the MSB and Q0 is the LSB, and the wires are SD0, SD1, SD2, then SQ2, then we have SA10, SQ0, SQ1, and we can have the assignments for outputs. Output Q0 is assigned as SQ0, then Q1 assigned as SQ1, and Q2 is assigned as SQ2, and then comes the instantiation of D flip-flop. DFF1 is our original module, and its instances are taken over here, 3 instances, DFF10, DFF11 and DFF12. So upon the execution of this, we will be able to find the values will be there for SQ0, SQ1 and SQ2, and that will be transferred over to Q0, Q1 and Q2 respectively. To get the exact values of the wires, we have a few more equations, that is SD2, then SA10 and SD1. That's all about the program, and hope you may have got a very good idea about this program. Yeah, this program uses structural modeling, and structural modeling is basically it uses instances, it uses It basically shows the entire architecture as interconnection of different sub-modules like flip-flops or combinational part like gates and all. The Verilog code for D flip-flop is shown over here. Its symbol is shown towards the right side, and it is having a D input, clock input, and Q and Q bar outputs, means QN output. And here we can have a preset and clear also. There are synchronous inputs, but I have not shown this because it is not important as far as this particular design is concerned. And as far as the code is concerned, the name of the component is DFF1, and it is having inputs D, clock, output is defined as reg, and we have two outputs Q and QN. With the reg we can make the variable store the data, and its behavioral model, so it usually starts with always at positive edge of the clock. If positive edge is detected, then of the clock is detected, then Q is equal to D, and Q bar or Qn is equal to not D. That's all about the program of DFF. The waveforms of the 3-bit synchronous counter is shown over here. Clock input we have, and the outputs are Q2, Q1 and Q0. Q2 is the MSB and Q0 is the LSB. That's all for today. Have a very nice day. Thank you all for watching this video.